us shortly. For those of you that were with us last week, very quickly, can you drop it on the chat? What has been your experience with Python since the last time we met? Just in one word, what has been your experience? A little reflection of what you learned last week and how far you've been able to go with it. Please kindly let's do that. I would love to just read as you're joining. And as you're also doing that, you can also tell us on the chat where you are joining from. Tell us what your experience was like in the last session we had a week ago. And also, tell us your name and where you are joining from. Which part of the world are you connecting from? Very quickly, as we do that, I will really flip through what we're having on the chat. Okay, good evening. This is from Adeniji Adetayo. Thank you for joining. Good evening, Julian Guyen, Wazim Izam. Go there. Okay. Oh, somebody said, great, quite interesting. That's the experience of a previous session. Oh, awesome. That is lovely. Oh, I have someone joining from Costa Rica by the name Andres. Oh, Andres, you are recognized. You're welcome. I have Nelson Jumidia from Nigeria. Oh, Nelson, it's nice to have you with us. I have someone joining from United States of America. That is Julia. Oh, Julia, you are most welcome to this wonderful session. We have somebody joining from Yemen, Thais University. Oh, that's Wazim. It's nice to have you connected with us. I also have someone joining from Lagos. That's Chika. If you are just joining this call, please tell us where you are joining from and tell us your experience with the last session we had a week ago. We have the video of the last session online. I believe some of us are already making use of the resources that's available online. Okay, somebody said, I learned new code in Python. Oh, this is quite interesting, quite interesting. Someone said he learns how to code in Python. That is Arthur David. Oh, this is beautiful. That's quite interesting. He said it's interesting class so far. I'm from Ibadan, Nigeria. Oh, it's nice to hear from you, Arthur David. I have someone also joining from Algeria. That's Kali. Kali, you are recognized. God bless you. I'm joining from India. Oh, that's Saba from India. You are most welcome. You are most welcome. You are most welcome. I also have James from Ibadan. If you are just joining the call, please, we want to see your reaction to the last session we had. Just give us your feedback, a quick feedback on what your experience was in our last session a week ago. And then also tell us which part of the world you are connecting from and your name. Okay, I have someone joining from Afe Babalola University, Nigeria, by the name Oladuni Kunlere. Oh, you are recognized. Last week's session was awesome. Oh, that's quite interesting to know. I learned how to code in Python. Oh, this is very interesting, very impactful class. Wow, that is beautiful. That is beautiful. That is quite encouraging for us. Good evening, everyone. I'm from Santiago. Wow, that's in Chile. Wow, that is quite interesting. Emilio, you are most welcome. You are most recognized. It's nice to have you connected with us. This is quite interesting. This is quite interesting. I think we have Dr. Chinagolom on the call now. Good evening, sir. Last class was interesting and engaging. I'm joining from Nigeria. Ellen, you are recognized. Ellen Alaho, you are recognized. Thank you for joining again. And I believe today's experience will be more engaging and will be more fascinating. We are set to learn more. We are set to interact more and engage more. Okay, good evening, sir. I am joining from Enugu, Nigeria. Last week's session was impactful. Oh, that's good to know. That's good to know. That's quite interesting, and we're happy to know that. That's beautiful. That is from Precious Ezine Ekweme. That is quite interesting to know from you. If you are just joining the call, please, we are still welcoming quick feedback from your experience of last week and a quick introduction of yourself, where you are joining from, and your name. We would love to actually know you better and know a little feedback about our previous session. Okay? Oh, I have someone by the name Mary joining from Kenya. Wow, this is beautiful. She's joining from Dedan Kimathi University. Last week's session was quite informative. Wow. We are happy to get that feedback from you. Mary, thanks for the feedback. Thanks for joining again. Thank you, thank you, thank you, thank you. Maybe we may be able to take more later, but because time is not always on our side, I will take this last one. I have someone also joining from AE Funai, Ebonyi State. The name is Exploit. I'm seeing here. I have someone joining from Lautech. Last week was an eye-opener. Oh, that is from Mulufunto. Thank you for that. Mary Dada is joining from University of Ilorin. Last week's session brought Python home. Wow, that's quite interesting. Adepoju Mary from Lautech, thank you. We are happy to get the feedback from you. He said the class was great and really impactful. We are happy to hear all of this feedback, and we are glad you are joining us again. We are set again today for a very interesting and also another very engaging session. Please pay attention. Feel free to use the chat. Feel free to use the tools that are available on this call. Like we mentioned last week, this initiative was put together by a number of consortium. It was made possible by a number of consortium. First on the list is the Neuro Nigeria. Neuro Nigeria. That is a new initiative that is starting in Nigeria with about 5 of us. We are trying to see how we can actually expand the frontiers of computational neuroscience in Nigeria. And then we have a number of us who are pushing that. Then we have support from Neuromatch Academy. I believe you know Neuromatch Academy. Last week, Dr. Peter was making use of Neuromatch material extensively. He is actually part of the Neuromatch Academy, and their resources have been very helpful, as some of us have testified in our testimony today. Also, we have Imbizo as one of our supporters. My humble self and Dr. China Agoro, who will be speaking with us very shortly. We were beneficiary, and we happen to be alumni of the Imbizo Computational Neuroscience School that is holding annually at Muizenberg in South Africa. So we were part of that, and Imbizo has been very supportive in this initiative. Thanks to... Okay, thanks to...
My phone is giving me problem.
Okay, what's the challenge you're having? Can we quickly address that? Just a minute, please. Dr. Chinagorom, can you go ahead and speak to us? Okay, I believe the conversation was not meant for us. Sorry for that interruption. Like I said, we have received support from a number of renowned academic giants in computational neuroscience. We have Peter Latan. We have a number of them. We have Tim Voge. We have Emma, the great administrator, who has been very supportive in that initiative. We've received so much support from these great people who are willing to actually also support us more. Also, we have other organizations like Center for Computational Science, which is also in a way connected to Imbizo, and many other organizations who have supported us. And this platform we are using was made possible by PhET's interactive simulation at the University of Colorado in USA. We will get to know a little more about that before we end today's session. And so without wasting much time, let me find out if Dr. Chinagorom is back online and she's ready for a presentation. Otherwise, we might need to start with Dr. Peter, and then we come back to our presentation. Dr. Chinagorom, have you been able to sort out your connection issue? Okay, if she's not here and she has not been able to sort out that, okay, I think she's unmuting herself. Can we hear you, Dr. Chinagorom? Are you set? Okay, Dr. Peter, I believe you are set for your presentation, right?
Yes, set.
Okay, awesome. So please, I will expect emojis as we welcome Dr. Peter for presentation day 2 on Python for computational neuroscience. Please, let's celebrate him. Yes, I'm seeing a clap. Yes, Chika, okay. Let's use the emojis to actually welcome him on board. Dr. Peter, over to you.
All right. Good day, everybody, again. Thanks for your kind comments. Last week was an introduction, and we tried to be patient with us. We are not by any means saying that we'll be impatient today, but the pace is going to be a little faster. You can also view this on YouTube live. So we are going to do a quick recap. Okay, so one of the things we did last week was to tell you that when you want to write Python, you can use different environments. Can you hear me, everyone?
Yes, we can, clearly.
Yeah, so there are lots of environments that you could use, but we decided to introduce Google Colab. So today, that's where we are starting from again, because some of you might be joining today for your first lecture. But please, to enjoy this session better, you need to refer to the first one that we had last time. Having said that, this is hands-on, okay? Our hands will really be dirty, okay? So you need to code along with us. So open a new tab on your browser. Open a new tab on your browser, and then type Google Colab. Google Colab. So what I'm trying to do now is to reinforce what we did last week, but not to repeat it, okay? So it's not a repetition, it's just a reinforcement. So if you click on your browser, you'll come to this page. This might not be your own first page. If it is, then great. Then you open Colab. And then one of the things that we'll show you today is that this platform is good for machine learning, data science, and for education. Last time we opened our notebook from here. This week we are opening from here. But before we open from there, we can look at some of the Please, can you mute?
Go on, please. You are muted. Unmute yourself, Dr. Peter. Dr. Peter, please unmute yourself.
Okay, yeah. Can I go on?
Go on, please.
Can you see my screen?
Okay, beautiful. Yes, we can.
Good. So I said last week we opened our notebook from here. This week, I'm saying we can also open from here. I now said that if you have time, explore, this interface. There's a lot that you can learn here. For instance, here we have AI and machine learning. Okay, so nobody learns Python for Python's sake. You learn Python to be able to use it to do stuff. So when you have time, just enjoy this wonderful resource that is on this platform. They also have data sets and all of that. I've also said that we opened a new notebook. This notebook is the environment where you are going to write your code. Okay, it's very interactive. It does a lot beyond just coding. For instance, it keeps updating this, release notes. So if yours has opened this way, then the best thing is to cancel the notes. You can read the notes later. This interface is exactly like, it's similar to what you have in most software that every basic computer scientist begins with, the Microsoft Word, Excel, and all of that. So if I click on code here, I will have a new cell. If you click on code again, you have an extra cell. If you click on text, you have a different kind of cell. And this cell can do a lot. For instance, you can insert images, you can insert emojis, you can actually write text. But I'm going to write some text in a very unique manner. If you're unable to replicate what I'm doing now, don't be too bothered. You have access to the video. So suppose I type content, for instance. Okay. This portion of this cell gives you the input, whereas this other side gives you the output. So whatever you type on the left is what you see on the right. But I can format this content. How do I accomplish that? I can put hashtag before it. Once you put hashtag before it, it increases the size of the text. If I click on this bold icon, I will make this thicker. Okay, so I actually want to show you the content of what I intend to share with us today and then next week, so that you have an idea when you are watching the videos. So first, I want to begin with variables, and that will just be a quick one on variables. Then after variables, we'll go back and quickly touch on input and output. One of the things that you will realize as I type is that this is producing bullet points. And the reason it is producing bullet points is that this syntax, which is just the minus symbol, produces an output which looks like this. So after we must have done output and input, I'm sorry, I have my notes here so that, you know, at the end of the day, I won't miss out. Then we can do strings, okay? And we can format the strings too. Then we'll talk about integers. We can then talk about floats and booleans. Okay? Somebody will say this looks like what we did last week. Then we'll talk about operators. So there's a lot for us to do today. We'll do control flow. And lastly, for today, we'll look at conditionals. So you see, what we have is a lot. Next week, we'll look at functions. We'll look at, I can call this modules, libraries, and packages. And then maybe we end with applications. In all of this, we are going to be touching on Neuromatch material. Okay, so without wasting much time, I can scroll down and remind us of how to create variables. I actually want to move this cell up so that it will be the first cell. So what do I need to do? I'll use this arrow here to move it up 1, 2, 3. So I have this as my content for today. So we are going to create a variable. How do we create a variable? We use text, okay, text. And the text could be numbers or letters, but don't start with numbers. And we said conventionally, we use small letters. So this is a variable, and I've decided to name this variable countries, okay? Then I actually want these countries to be a list moving forward. But for now, let's just start with basic. Let's take a country and say we take, for instance, China, for instance. The first thing you notice is that I've used quotation marks because this is a string. Okay, so I can put a comment here. We say we use hashtag, and we'll call this variable type a string. This is from last week. So if we introduce the print function, and then we write country in parentheses, what is going to happen is Python is going to check what is in the parentheses. Then it will see whether the variable has been created. If so, it will check for the value, and then it will print out the value. So if I run this cell, it's going to print out for me China. Okay, so this is different from if I come down here and I write print quotation marks and I put China. They are two different things. Here, we are printing out the text. But in the previous cell, what we're actually doing is we are printing out the content of the variable. Cool. That's fine. So, but today we want to show you that it is possible for us to pick certain items in that string. For instance, this string is a 5-letter word, and each of these letters occupy positions. reflecting on what we said last week, we said the first position is 0. So if I write print, which is a function, and I write country, and then I put a square bracket, the goal of this square bracket is to be able to locate specific characters in the string. So if I put 0 here and I print that cell, I'm going to have the letter C, because that is the letter that occupies the first position. So if I change this to China and say Japan, and I want to capture this part of the string because it's just one string. So I have China and Japan. How do I get that? If I want to print, I'll use the print function and then ask myself, where can I get this text? This text is in this variable country. So after print, I go to country and then square brackets to locate the starting point of this portion of the string. So if we count, the C is 1, so we'll count from C. 1, 2, 3, 4, 5, but we should start from 0. Never forget that. So that'll be 0, 1, 2, 3, 4. Then the space will be 5. So the start of that word, let me just put a comment here. Hashtag locate the text, and that's what we want to locate. So if I write 6 here, for instance, and I run that cell, I have an error. And you wonder why I have that error. And I told us never be too scared of seeing these bugs. So here we say string index
Hello, Dr. Peter. Hello, Dr. Peter, are you there?
Dr. Peter, we are not hearing you.
I believe we lost this communicate. We lost him. Let's wait, but I will advise, while he's trying to connect, please let's try out what he has been saying on our
Hello?
home. Okay, Dr.
Hello?
Peter, you are back. You need to reshare your screen.
Yeah. So it was electricity.
Oh, so sorry about that.
African problem. Nigerian problem. Okay, so can you see my screen?
Yes, it's coming up.
Can you see my screen?
Yes, we can.
Okay, good. So I was saying to us that if I run this line, I will have this error. And why will I have that? The value so that I can manage my source well. Sorry, please. Hello, Prof, can you still hear me?
We can hear you, but we are not seeing your screen again.
Yeah, you see my screen. Can you see my screen now? Now I have to run. Okay, so
no, we are okay. Bring it up. Yeah.
When I ran this line, there was an error, and the error is index error, which says that the string is out of range. The reason for that is I'm asking it to give me the character in the 6th position. Meanwhile, what it recognizes is that the country is still China. no longer China and Japan. Okay, so I have to go back and run that line so that it will change the content to China and Japan. Then if I come down to run that cell, you will have it give us an output, which is the letter A. It should be the letter A. Why is it the letter A? Because like I was saying before now, I said if you count from China, you have 5 plus space, which is 6, but that's 0 to 5, and this would be, the A will be 6th. So if I want A to D, what I'm going to have is I'll write colon in front of this, and I'll say add 2 more positions. Of course, 6 plus 2 is supposed to be 8, but it's not going to capture that 9th value like we said last week. So you now have and. The good thing, like I said, we have opportunity to, moving forward, let's now create several variables, okay, and see how that will help us. So if I have a variable called name, let's say Peter, and I have another variable called age, let's say 30, I have another variable called say height, let's say 1.6, maybe I have another variable called is male, and I go and put say hobbies. Okay, so I'm trying to save time. That's why I'm doing all of this way. And I say quotation marks sports, or let's say soccer, for instance. And then let me just add one more. I say music. And then say we have another which other thing? Okay, let's say we have what skills? Let's say skills now. And then we now have something like this, say coding, and maybe what else? Teaching. Okay, so here we have 6 variables, but they are all of different types. So if I go to the next line, let me run this line. Let's see if there's any bug. Okay, that your code runs well does not mean that there's no bug, but it's an indication that at least we've done something right. So if I type name, okay, and I cast that name into a function called type. What I mean by that is if I want to know the type of variable that name is, the function that I'm going to use is the typ function. So here it says that the variable is a string. So str for string. So please, can you help me in the chat and tell us the kind of variables that you think these guys are? Maybe I should put this one in a bracket. So just type in the chat, say something like age is so and so, height is so and so, and all of that, because I'm going to complete this. So while you watch me, why not type? So I'm going to say type. So I have type what now? Type age, type height. Can somebody unmute and tell us what you think some of those variables, what types you think they are? Anybody? Anybody? Am I alone here? Somebody wants to help us? Wow. Am I alone? Am I still on? Oh.
Yes.
Yes,
I'm not alone. Okay, I'm not alone. So I have to. Okay. Okay. So age should be an integer.
Age is an integer, sir. Height is a
Fantastic.
float.
Brilliant.
Is male is a boolean.
Go on.
Hobbies are all
Is a list.
Strings. Yes, they're all strings. Skills are also strings.
Is a list.
Oh, true, sir.
Now, do you see that the output of my code is tuple? Then you wonder what has happened. What has happened is that because I did not say it should print, it's only going to give me the result of the very last one. So indeed, what I should do is to put print in front of each of them. That's what would make this thing easy. So there's a shortcut that I could use to write print at the same time for all of them. So what I'm holding down is Shift and Alt. So if I write print now, you see, it picks everything. But at the end, I have to come to the end here to now put each of the brackets. I'll take that again. Because I have the same function, which is one of the things we are going to learn in the coming days, is not the best practice to use a function again and again. But for the purpose of teaching this today, we have decided to type each of these different types of variables. Okay, but now we are not going to call them variables. We are going to call them data types. Okay, so this is a tuple and this is a list. So I can come under here and write a text, and I could say use square brackets, okay, for list and parentheses for tuple. So the question is, what's the difference between a list and a tuple? A list is mutable. What it means is you can manipulate a list. You can add values to a list. You can remove values from a list. But with a tuple, you are not able to do that. Okay. And then some of the things that I might not necessarily explain to us here are things I believe might not be directly related to computational neuroscience, or that you can easily read on your own. So what we have done so far, if we go back to our agenda, is that we have looked at variables, and in a way we have talked about data types. Okay, so let's move on, because what I did was I touched on strings a bit. So what do I want to show you? I want to create a new tab. I want to create a string, and I want that string to be first name. That's the name of the variable. And I want that to be my name, say Peter. But one thing you see here is that this Peter is in capital letter. So if I decide to receive input from somebody and I say name, and I ask for the name by using the input function, if you remember from last week, and I say, what is your name? Okay, for instance, maybe I put a question mark and put some space. By the way, I'm deliberately carrying us along this way so that you can also match up with the speed, okay, that I have. So if I don't want to use this for now, I can comment it out. So that's one of the things we said last time. When you comment out, Python ignores that line of code. And it's a convention in many programming languages. So if I run this line of code, it's going to wait for an input. Okay? So if it waits for an input and I write Peter, which is not too elegant. So what can we do? We can format this string, okay? And then we can now say that we'll put our F string and we can write my name is, then I'll put a curly bracket here. Or maybe what we should do is, let's take this a step at a time. Let me ask a question. The question I want to ask is, if I write this code this way, and you see this squiggly line and this red coloration, what does it indicate? Somebody wants to help us. What does this show when you code and you see, these red markers and this squiggly line? Anybody?
Yes. It means that the word you have
Yeah, go on.
used, the is an inbuilt function.
Good. 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 And since it's a function that is inbuilt, have equal numbers of parentheses. So if I run that, we'll be fine. Whatever, if you change the name to John, it will print out John. So there's nothing really happening. Therefore, we need to learn all that concepts that will help us do something that is more operators. Okay, so I'm going to triple quotation marks, and I'll call it useful in programming. And we are going to categorize these operators into first assignment operators, and then we will have arithmetic operators, and then we can talk about maybe logical operators, and finally, for now, relational operators. If we can do this, it means that we have been able to understand integers better, because the idea I have at the back of my mind is to introduce you back to integers and then use these operators as my tool for instilling the learning into you. So if we create, let's say we create a variable and we call the variable numbers, and we say number is equal to 3. Fantastic, it accepts it. Why? Because we have used an assignment operator. So the single equal to is otherwise known only assignment operator. We can go back and maybe we change this to, instead of numbers, let's just give it number. We can now increase this number by saying number is equal to number plus 1. If I do number plus 1 and I decide to print number, let's read this block of code, because now we are moving from lines of code to blocks of code. That's the progress that we have made so far. Okay, so we have 3 lines of code. In this first line, we have created a variable and we have instantiated with the value 3. In the second line, we have increased it, yet we are using an assignment operator, which later we are going to modify. If we print number, the value will no longer be 3, the value will be 4. Why is that so? Because what we have done is we have increased the number. If we change the operator here to negative, and we run this line, what we are going to have is subtraction. So what we have done so far technically is that and we have already seen 2 arithmetic operators. What are the arithmetic operators that we have seen? We have seen addition, we've seen multiplication. Addition and subtraction. If I change these to asterisks, and I change this number to say 10, if I run this line of code, what is going to happen is it will read from right to left. It will look for number and check for the value where it was created, and then multiply that value 3 by 10, and at the end of the day, we have 30. What happens if I use forward slash? Forward slash is going to divide, and then we have values in this form. I think this is getting a bit interesting. But just when you think that variable, and I call it num, and I put the number, say 30 here, and I say print, say num star 2. It means that we have included a new operator, even though these operators could be tagged as arithmetic operators. So apart from addition subtraction, multiplication, and division, we also have exponential. We have our floor division, and then we have our modulus. Don't worry. When you learn Python, there are so many tools online where you can, quickly access them. So for instance, if I go to my browser and I click and I type arithmetic operators in Python, for instance, I could even add examples if I want. Okay, and this method that I'm using now, I'm going to use it again and again and again today, because the goal of this part of the training is not just to show you that one knows it, but to help you so that you can learn on your own. So if you can see my screen, you will see that we have addition, subtraction, multiplication, division, and then floor division. This floor division is // and then there's the modulus. Okay, so there are 6 of them. Okay, there's exponentiation, which is double asterisk. How do we apply them and what do they stand for? So let me scroll down and demonstrate them. So I'm going to say print. Let me make this number a little, friendly. So if I take 5, what's the other print that we have? Num 2, and then I do print num, say, these are pipe symbol, say 4. Let me print out the results and then tell you what is happening. That will really help us. Okay, so what is happening here is that it takes this num, goes back to where it was created and finds that it's 5. And this 5 in front of here is simply num raised to the power of 2. That's what is happening. So if I copy this line, for instance, I can copy this line, and I put 3 here, what is going to happen is going to multiply 5 by 5 and 5 again. So this is the next one is going to give us 125. So this is 5 multiplied by 5. This is 5 multiplied by 5 and 5. This is 5 divided by 2. So the question is, when I divide 5 by 2, in how many times will 5 go in 2? Oh, sorry, in how many times will 5 go in 2 go in 5? So 5 divided by 2 is 2 with a remainder. I could make this number bigger, say 50, so that you can see what one is saying. And then I can change this division here to 7. I want it to capture this. That's why I'm changing the values. So if I run this line of code, this one is 50 multiplied by 50, or 50 to the power of 2. The other one is 50 to the three. But here we are dividing 50 by 7. So if you divide 6, the whole number, which is 7. But if I decide to use this pipe symbol here, and I run that line of code, it's going to give me the remainder of 1. So while this refer to it as floor division, uses the whole number on is, the mode. I'm going to pause here and ask 50 by, if I divide 50 by 4, that would be 4 times 12 is 48. So this should give me 2. So that's why when you run this, you have 2. Let me allow us to unmute. Let me hear 1 or 2 comments and find out whether this made sense. Did this make sense to us? I hope I'm not alone.
You are not, sir.
Hello?
Yeah, it makes sense.
It makes a lot
It
of
makes
sense.
sense.
Yeah.
Makes a lot of sense. Thank you, sir.
Okay, good. So I've been asked to share my video, but I can't share my video because I don't have electricity here and this place is super dark.
Okay, no problem. So that's fine, sir.
Okay. So sorry about that. Okay, to do with my work. Okay, good. We're making progress. So we have seen some operators. We can always check them back to one of the things that I showed us earlier on, and let's see whether we can make sense of the next line of code I'm about to write. So if I have something like say length, and I say length is 20, and then I now say length, and I say length is equal to length asterisk 20, or say asterisk 2, and I say print length, and I run that cell. Let's see whether this makes sense to us. If it does, I'm going to comment in another way. I could say length and then put asterisk equal 3. What I have here is similar to what we have above, except that I've changed the value. If what I said makes sense, I will want us to go to the chart. You know, I'll be so much interested in the chart if we can give us an idea of what this value will be. If I run this line of code, what is going to be the result? I can't see the chart, but if Prof can help us, if there's any comment in the chat and you want to share with me, please let me hear that. That's an exercise. What would that produce?
Okay, someone is saying 60. That's from Mary Dada. 60 from Chika Ojiako as well. Tokwe, 60, 60. So we have 60 from most people.
Great. That's fantastic. That will be 60. So let me digress a bit and then show you again how much progress we are making. The beautiful thing about what we are doing here is that it might appear to you as if we are not making much progress. Yes, it could be so, because really speaking, the progress we are making is not as much as one would have, expected if we had a live class, but I don't think we are doing too badly. So one of the platforms that I like to introduce to people when they are learning Python is W3 Schools. Okay, so one of the things that was asked when we started this program last week was, are we going to provide us with resources that are, good for, for us to continue with? Yes, the truth of the matter is W3 Schools is a wonderful platform. If I go to W3 Schools and I look at Python tutorial, by the way, there are many others. There is Coursera, there's FreeCodeCamp, Udacity, Udemy. There are many, there are several, okay? But why I like W3 Schools is that you can also code on the platform. That's one. The other thing is on this platform, you can learn so much. It's not the only platform, although one might not have the time to show you several of them. But just imagine you on this page, young person who is trying to learn computational skills, and you have a platform that can teach you HTML, CSS, JavaScript, SQL, Python, Java, and so on. And if you continue here, C#, React, jQuery, and so on. This is a wonderful platform. So what I think
Oh, it's like we lost Dr. Peter again. Okay, please.
Wow.
We
I
lost
lost connection, right?
Okay, yes. You're back now.
Yes, I'm back. I'm back. Yeah, we'll be fine. We'll be fine. What to do when we are done with these 3 weeks? Feel forward. Can you see my screen?
Yes, we can.
So, by the way, when you are done, I guess somebody must have said yes, right? Were you seeing my screen? Hello, everyone. Were you able to see my screen?
Yes, sir. Right now, your screen is visible, sir.
Yes, we can see your screen.
But you have left the page for the tutorial.
Okay. Okay, thank you very much. So I was saying that there are resources. Wow. You can't see my screen again. My internet is.
We can see. Okay.
Wow. Okay,
Dr.
good. So I said there are
yes.
exercises, there are references. You could even get, Okay, good. Okay. You could also get a certificate. Before I explore this site, let me go and show you another one. You can go to YouTube and then type CS50. So you can go to YouTube and we can do CS50 Harvard Python programming. Yeah, I know I have to share these things with us. So what I'm going to do is I'm going to go to this 15 hours course, and then I'm going to copy this link. So I'm going to now go to our chat, drop it there. I think these things are some of the most important things that I plan to do. And now that I'm able to do them, I feel very fine. Great. So you have those 2 links there. But let me come back to this Python tutorial. If you look at the way the tutorial is arranged, you will see that it begins with an intro, then it talks about syntax, output, comment, variables, data types, numbers. All of this we have done. I'm telling you, somehow we are somewhere here. So within the short time that we have interacted, we've been able to touch on some of these things. But that's not enough. What the next level is to, pick any one of them. Say, for instance, we pick Python list, and then we come to Python list. It gives us an example which you can copy and paste in your editor. But that's not all. You can read and understand what lists are. And then you can go ahead and see examples. And then you can try this yourself. It has, an interface where you can, code. It's not just you can code here. By the way, I can change this banana here to say apples. Okay, I can come here and change these bananas to apples and then run this code and then it will replace it. So that's one of the other advantages of using this platform. You can code along, okay? So I'll leave you to explore it, okay? And it's not just going to take you through Python. It will go down and bring in some machine learning, okay? So if you follow this through, you'll be learning data structures and algorithm. You'll be learning MySQL. You'll be learning MongoDB, just in one course. So let me leave that. And let's move to the most important website for now. And that's why one of the reasons for organizing this program. So open a new tab and type computational, or let's say Neuromatch Academy. Neuromatch Academy. Okay. And then press enter. neuroscience. I'll get to the link and then put it in the chat. By the way, guys that are on YouTube Live are not able to get this. Of course, when they watch the videos, they will have to slow it down and then try to check for the link. And we are going to attach it to the video, to the YouTube video before, after today's class. So I don't want you to go to this first page. I want you to go to this next page, because this is where our work now gets so interesting. So what am I going to do? Can I share this link? Yes, I should share this link. What is the story behind this link? Computational Neuroscience by Neuromatch Academy had a slide challenge. My experience with students reveals that if they are able to master, they will do very well. So I discussed with my colleagues, and we agreed that it's a nice idea to introduce learners to this platform. And then along the line, we found out that it will also help students who want to, attend in BIZO and the Trend and all those other conventional schools. So let me talk about this platform, which is free, it's open source. I have the permission to share with you, and I also want to encourage you. So in July 2025, now 2026, we'll be running a 3-week program. That's Neuromatch Academy, from the 6th of July to the 24th of July. We'll run 4 courses, one of which is Computational Neuroscience. The other courses are Deep Learning, Neuro AI, and Climate Science. Those are the courses. For us here, we are focusing on Computational Neuroscience. Now, this pre-course material contains videos that you are supposed to watch. Moving forward, you are going to be watching those videos on your own. And then as you check down, you will see that there's something about pricing. And then I want to show something that Neuromatch Academy has done that is, very impressive. Even though the cost of the rates are varied depending on your location in the world, you could also calculate it before the program. So let's say I want to calculate my fee. I will click on that link, and then you can read all of this. Okay, I've read this, so I understand what is there. This course, Deep Learning, is about $1,000. Okay, but that's the baseline fee. If I, as a Nigerian, and we have a lot of Nigerians on this call, if I put in Nigeria here, the cost becomes $99. If I change the cost to Computational Neuroscience, and then I say that, listen to this, will your tuition fee be paid for or reimbursed by employer or supervisor? If I say yes, it will be $99. But if I say no, it will be $49 or $54, as the case may be. So what am I trying to say? This is a ridiculous amount to learn at Neuromatch in July next year. Because for me, the learning is not what the TAs will teach you. It is more about the social learning that occurs when you are with your podmates. That's what we call them. There's so much of, social learning that takes place, peer learning, they call it. So I'm going to encourage us to play with this material. Make sure you understand it. I mean, the pre-course materials, so that when the registration begins in February, you'll be confident enough to tell the level of Python skill that you have, so that you
Hello, Dr. Peter. Dr. Peter, hello, are you there? Okay, it's like we lost him. Dr. Peter, can you hear us? Okay, while we are trying to get Dr. Peter back, can we also try our hands on some of those resources he's trying to give us, and maybe a quick feedback on the chat? We can quickly discuss down before we have him back on the call. A quick feedback on the WhatsApp, on the chat, can really help us to be able to track. Or if you have any question you want to ask about what he has been teaching us or showing us so far, you can also do that one. The host can give privilege for you to unmute yourself so that you can ask question while we try to wait to have him back.
Am I back?
Okay, you are just back now.
Yes, you have. Yes, you are, sir.
Am I back? Hello?
You are back.
You
You are back.
Welcome back.
Hello, Dr. Peter, can you hear us?
Yeah, I don't know what I was saying, but I assumed that I was sharing the Neuromatch material. And me. Hello,
Exactly.
Can you hear me?
Exactly.
Hello?
That was what we were doing.
Hello? Can you hear me?
Okay, we can
cool.
hear you loud and clear.
Nice. Okay, so let me share my screen. Is my screen showing?
Yes. Then you need to bring up that page. Good. We can see the screen.
Good.
Yes.
Good. So I was to encourage us to ensure that we do this material. So how did I get here? Let me try to get here again because I lost connection. What you just need to do is to create a new tab, type Neuromatch Academy, Computational Neuroscience, and then I don't want you to pick the first page. I want you to pick this one. Okay, when you've picked that page, I want you to scroll down to the point where you will get the notebook. So we want to get the notebook, work on the notebook a bit, go back to our table of contents, see how far we can go. So if you can see my screen here, the 3 weeks course begins with introduction to modeling. And then there's machine learning. And then we now start talking about dynamic systems and stochastic processes. So these are very heavy courses. If you come to the summer school without this prerequisite, you will struggle a lot. So what we did at Comp Neuro Nigeria is to come up with a workshop where you can learn Python workshop. Okay, learn Python for computational neuroscience at the very least. Besides, it's this same tutorial that you need for the other programs such as deep learning, neuro AI, and the climate science. So when you get to this page, you move to the first tutorial. The first tutorial is on this leak integrate fire, model, and Professor Olayinka is going to take us on this tomorrow. I'm sorry, next week. He's going to take us on a session on this because that's where it starts from. Okay, very basic. So what do you need to do when you get here? You actually can open in Kaggle if you have a Kaggle account. You also can open in Colab. So, but we are going to open in Colab like we did last time. When you open in Colab, the file that you are going to be given is a file that is for Neuromatch Academy. So you have to save this in your drive so that you can recall the changes. And we did this last time. So what do? You go to File, and then you save a copy in Drive. some of these things we did last time. So we want to continue from there. We want to engage with this material, get used to it, so that between now and next week, you would have understood how this material works, and it will be very easy for us to build on whatever is left for us to, work on. So the moment you do that, you have a copy of, the notebook. If you don't have a copy of the notebook, you are not going to have your changes saved. Good. So what do we have in this notebook? This notebook contains text. So if you are going to use this notebook, you should start really by maybe closing this table of contents so that you have, more room. Okay. So this portion is a text file, just like the one we built. If we go back to our own started by having this initial page. So this initial page is similar to what they have here. Okay. Then there's a blank page here where you can, personalize it. You can put maybe double quotation if you like. Let me put double quotation. And let's say double and say my notes, something like that. So that you know that this is your notes. If we move down, I will leave you to read this, okay? But we want to focus on this last paragraph. Each new concept in Python will unlock a different aspect of our implementation of the leaky, integrate, and fire neuron. So next week, Prof will take us through this so that we'll have a practical understanding of what this neuron is about, and then build on it as we continue with statistical analysis. Okay, so we'll visualize the evolution of the membrane potential and extract statistical properties. That's what you will see in these very long notes. So if you have done the same thing, there are certain cells that you need to run. Okay, they are called helper functions. They are already built-in code that you can, run just by running that cell. Makes it easy for you to reproduce the results, have the graphs and the plots. So what are they? Very simple to use. And I'm glad that we even got to this point, because if we had not done introduction to Python and the use of this Colab environment, this would be very difficult. So what do we have here? I want to show this code. So you don't actually need to do all of this because this has been done for us. Okay, so all you need to do in this cell is just to click on play. And what does that do? That begins to open up this page. Once you see that it has shown you this RAM and disk, it means that this cell is already being prepared. But it will take time. Why? Because we are installing packages. And this is one of the benefits of using cloud-based platform. If we were using the other platforms that we download on our systems, we have a lot of issues. So run that and ensure that it's already working for you. And then we'll come here and import libraries. We'll talk about libraries next week, especially these two that you see here. So there's a library called NumPy, basically for numerical analysis. So if I like, I can come here and write for numerical analysis. And then I can use this and write for visualization. Okay, so you use Matplotlib, and these are not just the only libraries, but for this first lecture, we need to import NumPy and Matplotlib. We'll talk about these two libraries next week, hopefully. So all you just need is to run that cell, and then when you scroll to the next one, this code is also already written for you. You don't need to understand what is here. But one important thing I want to highlight is the fact that it is built using Matplotlib. It helps you to have, a space where you can, print your graphs using layman's terms. So what do we have? Python basics and the leaky integrate fire model. Here, you are supposed to watch a video. Okay, so what I will do now is to go back to Neuromatch Academy Computational Neuroscience, and then I'll pick this first one. Remember that I didn't pick this first one the other time because of what I wanted to show you. What then is the difference between the two? The difference between the two is that in this new one that I'm trying to put on the chart, you have access to the videos. But in the other one, you have a link to the YouTube videos. The lectures are usually made up of videos and text. So when you watch the video, then you now go to the text, and then the text makes more sense. So this cell is actually for you to play the video and watch this. This first video, I think, is for about 11 minutes or so. You can see here that it says watch video on YouTube. But if you use this other, material, you'll be able to watch the videos. We are not going to watch the videos live here. You are going to watch the videos on your own. But what we can say is that after watching the videos, an explanation of the text follows. Okay, so here we can, give feedback by just clicking that. Then we now have an explanation of the first video. So what is it that is the biggest problem when it comes to computational neuroscience? The biggest problem with relation to coding is that being able to translate this mathematical expression to code that can be executed, that's the challenge. So I will leave you to go and read this membrane equation. But you see, computational neuroscience is not for people who first are not in the sciences, because it's computational neuroscience. But even if you are not there, then you need to learn a bit of physics, a bit of chemistry, a bit of biology. Because at the end of the day, for these things to make sense to you, you must understand what we mean by, potential difference. You need to understand what we mean by resistance, current, and all of that. So here we have mathematical expression of how the leaky integrate and fire neuron looks like. And there's a bit of mathematics there. There's a bit of ordinary differential equation, which brings me to something that one needs to highlight. What is that thing? The fact that beyond just learning Python, you also need to learn a bit of maths. So I will leave you to read this content. But I will move on to show you that I have like 10 minutes to the end of my session. I want to show you that there are exercises. For instance, after watching this second video, which is about comment and strings, which comment and strings we have already done, in our tutorial. Of course, this video is going to tell you about when to use comment and how to use comment, which we have done. And then our only exercise for today, because of time, is this exercise, which is very straightforward. Let's look at it. It says here, defining parameters. That's our only exercise. It says we start by defining and initializing the main simulation variables, not the word variables. So the question now is for our leaky integrate fire neuron. Which side of the equality sign are the variables? Are they the ones on the left or the ones on the right? The answer is clear, the ones on the left. Okay, so here we have maximum time, change in time, tau, and so on. But what's the question? It says, in the code cell below, please modify the code to print the simulation parameters. I'm going to give you 1 minute to look at this and ask yourself, what can you do to this cell so that you can produce this result? If you know what you can do, go ahead and do it. If you cannot, wait for us. Next week, we are going to go back to that mathematical expression and then interrogate it further so that we can plot graphs and all of that. if it's possible for me to just check what is happening in the classroom and then come back quickly. Let me see. If you can do it, say yes. If you can't say no. Let me just watch for a few seconds. You can attempt it, just say yes. You have an idea. If not, okay, so this is how easy these neuroscience materials can be. You can not, if you run this, you are not going to produce any results. The reason is that everything has been commented out. So what you need to do is just to remove the comment from each of them. And as you remove the comment from each of them, even the color, okay, so in this first exercise, there are variables from some of them are measuring voltage, some are measuring resistance and all of that. And I also have to do the same thing with this print. Don't forget, this exercise is about trying to see if I will get the same results, and they're exactly the same results. So what is it that I will expect from you next week? The fact that you will have watched the first 2 videos, and then you come to tell us that, yes, I have an idea of what is happening here. Let me spend the last 5 minutes of my time to introduce you to loops and conditionals. If you are able to get these 2 concepts, then I'll be very glad that we have done sufficient work for today. And then Dr. Chinagron will come up, and then Prof will also come up. So here I want to talk about the for loop. First question is, why do we even need a loop? We need a loop when we have a task that is repetitive, okay? It is not efficient for you to code and then waste resources and waste time. There's what we call time and space complexity in coding, which is, these are a bit advanced concepts. So what are we saying? We are saying whenever you discover that you are repeating, a task, then it's important for you to think of a solution. So one solution is we can create a for loop. What I want to do today is to just show you the syntax. It's the syntax that matters to me today. So let's assume that I have a list. Let me call it list 12. And in that list, I have 1, 3, 5, 7, 9. And maybe let me add 10 to it. Let's just read this. And I want to multiply each of these numbers by 2. But one way is to say print, watch this. I can say print list 12 square bracket 1. Okay. Then I can put asterisk in front of it and say multiply that by 2, and then go to the next number. That will be very efficient. So it is in this kind of situations that you can keyword for. So we can say for number inside this list, but the Python word is in. So for number in list 12, and this is beautiful about Python because it reads like English. So for number in this list, that means for each number in this list, that is for 1, for 3, for 5. So if we have a list of 100 numbers, that means we are going to code more efficiently. The syntax is such that at the end of that, variable, you put a colon. So it's a syntax. If you go to W2 schools or wherever, you see these things there. Once you put this colon, you are creating a block of code. If you press enter, Google Colab will move this cursor forward. It will not be at the same point as 4. This is called indentation. When you go to the resource that I've given you, you will see some of these terminologies and they will help you. Thanks. Number. If I run this 1 to 10, 1, 3, asterisk 2, and I run it, and at the end of the day, we have 2, 6, 10, and all that. It's going to take each of the numbers, and then it will find the square of, we have 1, 9, 5, and 6. Ignoring this list, I can say I'll create a new, whatever number I put here and count 6 numbers. So, and I say print number for me is from 0 to 5. Just a quick modification. If I put a formatted string and then I write and I put colon and I do my curly brackets and I say squared, okay, squared, I can spell, is, maybe I can do number asterisk 2. Let's see whether this works. So it says I have a problem. Why? Because the string is unterminated, which means that I need to come here and put quotation marks. If I run that, I will have, let me just read this line and I'll stop here. Okay, I'll stop here. So this reads as 0 squared is 0 to the power of 2. So it just goes, imagine that what we have here is 46, and I run that to just go down all the way. So let's stop here. Again, if you try any exercise and you don't get the answer, there is always this opportunity to check for solution. Thank you very much. Sorry about the electricity challenge and all of that. I wish there was more time. Let me hand over to Prof. Prof, back to you.
Wow, 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 wow. Please, can we celebrate Dr. Peter for that wonderful, 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 great presentation. Please, I'm expecting more emojis. Yes, I can see a number of us celebrating and clapping. That was a great one, Dr. Peter. Thank you, thank you, thank you for opening our eyes. According to a quote by Shiv Kera, he said, and I quote, "The schools will only show you the fountain of knowledge. However, some students might drink, while some might just gargle with it, while some will just zip." We have been exposed to so much of knowledge and information today. I believe it won't be among the few ones who will just gargle and walk away. Please, let's drink and drink and drink until we want no more, please. He has given us so much information, which I believe if we leverage on all this information and the links, we can actually be experts in various fields of endeavor, and then also even become part of the frontiers in the computational neuroscience. It's an evolving field, and so much is happening in that field. So much fund is available. So please, let's feel free to be part of this development. Thank you once again, Dr. Peter. Without wasting much of our time is fast moving. We have another presentation to be anchored by Dr. Chinagorom. Dr. Chinagorom, over to you. Let's welcome her with some emojis, please. Dr. Chinagorom, over to you. You can share your screen. I hope she's there.
Yes.
Okay, great. Okay, great. We can see your
screen. Can you see my screen? Good evening, everyone. Can you hear me?
We can hear you. Yes, we can hear
Yes,
you.
loud and clear, ma. We can hear you.
Okay. Good evening, everyone.
Good evening.
Sorry, I must apologize. I was supposed to start before Dr. Peter, but I had issues with network. It was so unstable here. So we've been talking about, first of all, I want to appreciate Dr. Peter. He has done so much work, because I remember the first time when he was running that life run, I just remember my experience. The first time I entered Neuromatch, it was horrible for me. That was my first encounter with Python. I didn't find it funny. I did Neuromatch 2021 and I could not complete it, and I never asked for my certificate. It was a terrible experience for me. Dr. Peter, well done. We appreciate you so much. So we want to this night look at Introduction to Computational Neuroscience. Of course, a lot of us have been hearing about computational neuroscience. Some of us have not encountered it before. And it's a very fascinating field, a field that's fast evolving and a very engaging field. And for some of you that want to dive into this field, you're all welcome. It's a field that has taken so many of us to different countries, and we are so much appreciative of this field. So I will begin by, first of all, kind of a career trajectory, how I moved from anatomy to computation. I call it from moving from anatomy to algorithm. Okay, so my first encounter with computational neuroscience began with Neuromatch Academy. That was 2021. Like I said, it was not a very good experience with me because it was my first time of meeting what they call Python. So I struggled. Though 2023, fast forward back to 2023, I saw an advert about Imbizo. I remember my experience with computational neuromatch. I said I wasn't going to apply. So I just told myself, forget about it. You see that program that you don't like, that is pointless, wasting your time. But funny enough, I left it after some time. So one day I remembered it again, and the day I remembered it was the deadline. I go home, quickly apply for it. I did not apply for me to be selected, but funny enough, I was selected. I said, okay, maybe that's the way God wants it. So I'm doing this because I want to acknowledge these bodies, these communities, because they have actually, shaped my career trajectory in the field of computational neuroscience. So after my computational neuroscience experience at Imbuzo, South Africa, it was a very fantastic experience. I was able to go to UK through my Professor Peter Letham, one of the organizers of computational neuroscience in Bizo. I got to Gazi Computational Neuroscience Unit, and the idea was to go and get the quantitative knowledge, which I don't have. Because computational neuroscience, as you see, is not all about the Python, It has a lot on it. It has a lot. It has mathematics, it has physics, it has computer science, it has even those in electrical electronics engineering, because they have to bring the programming knowledge, which is the Python you are learning today. So I have to go and get my hands dirty in all those quantitative skills, which I lack because I am coming from the biology background. I don't have the quantitative knowledge. So I moved to Gatsby. I spent my 6 weeks at Gatsby Computational Neuroscience, learning all manner of, mathematics, different types of mathematics I've never encountered in my life. It was also not funny. So from there, I was also accepted to attend Trend. And I also did African brain data, which also we analyze data that has to do with MRI. So finally, 2020, this year, 2025, I was a member of, I was a faculty at BioRTC, Yobe State, the first computational neuroscience that was held in Nigeria. It was at Yobe State, July this year. So having said that, I'm only saying this because I want to acknowledge this community. They have really done so much for me. And I know Prof. Akinola has also benefited from this. So we want to understand what this computational neuroscience is all about. What is computational? Because when I talk about computational neuroscience in my school, I talk to my students, they're asking, what is it all about? People don't understand it. If I want to borrow this night, I want to borrow the words of Professor Akinola, that said that computational neuroscience, nobody can claim that is domiciled in their field. It's a field that physics people cannot claim it. Mathematics cannot claim it. Okay. Computer science cannot claim it. And even those in anatomy. As an anatomy lecturer, we understand the structure, but we don't do the function. Physiologists do the function. Okay. So, but then again, we need to go to the mathematics background, look into physics, and look at the mathematical equations, the algorithm they have to understand how the brain works. So I see computational neuroscience as a discipline unifier. It has unified disciplines, okay, bringing these people together to say, bring your own knowledge, bring your own knowledge. I have the structure as an anatomist, but I don't have the quantitative skill to understand how the brain receives and processes information. So this is what computational neuroscience is aiming. Let's see how we can model the activities that go on in the brain. So this is what it's all about. So I've defined it here as computational neuroscience applies mathematics, physics, computer science, neuroscience to study the brain function. It aims to understand how the neurons compute and communicate by developing models and analyzing neural data. That's exactly what computational neuroscience is all about. So, sorry, I have to bring this thing down. So the question is this: what is the goal of computational neuroscience? The goal of computational neuroscience, like I said, is that it processes information. Yes, as human beings, as I'm talking, what I'm saying now, your brain is actually processing it. So when the brain is processing information, you want to know what mechanism is this brain is using to process this information. As I'm talking, your brain is picking the information and it is analyzing it. Okay? So we'll actually have to analyze it. So those information could be by the one I'm talking, it could be by sensory information. So we analyze the information by analyzing data. We can actually go through interpreting this data by getting EEG, okay, data set, fMRI, MRI data set, and spiking trend. When we have to do experiment, maybe at that point, we have to implant electrode in a rat or anything, just get information and see how the neurons, send signals to different neurons. Because we know that the neurons, we have about 86 billion neurons. And the complexity of the brain lies on the fact that it synapses about 10 trillion times. That tells you that one neuron have to synapse about 10,000 times for one neuron. Okay? So the goal is to build model. We want to build model and also want to stimulate, brain function in large scale, do some simulation about the brain function. This is blocking me. Hold on, sorry. So we now look at the next slide I have here is about scientific loop. Computational neuroscience operates in the intersection of 4 pillars. Intersection of 4 pillars in the sense that you must do an experiment, okay? Gathering raw data from brain. It could be neuropuzzles, it could be electrophysiology, it could be patch clamp, okay? So when you gather this data, the data has to be process signal to find patterns. And the idea is we want to find the patterns, neural connectivity spike, and also make correlation with them. Then at the end of the day, what do you do with it? You have to build theory and models, generate testable hypotheses, and explain why the brain works in this way. So at the end, after generating models, you can now make prediction and validation. Use models to predict and design new experiments, and also iterate to refine understanding. And also, it can also help you to use to, design new drug therapy. So what are the scales? At what scales do we study computational neuroscience? There are different scales. If you look at it, it could be sensory input, like I said. Just you looking at somebody is sensory, okay? It could be by language. These are the scales we are looking at. And it could be by what? Perception. These are the different, the whole thing. This is what the brain models in per se. What I'm trying to say that the brain models sensory input. perception, recognition, and attention. Learning, the brain has to model it by using mathematical equation, okay, by using so decision making. So, and these things are done in different scales, and the scales could be from the molecular level, which can be ion channel. And when you talk about ion channel, you might be talking about Hodgkin and Hussey equation and neurotransmitter. So that is the ion channel. So it can also be by synapse. Of course, we know what happened in the neuron, that the neuron, the dendrite will move information. It's like it receives input and also synapse with the other neuron. And that is the way the neurons connect. So the way we communicate as human beings, that's the way the neurons communicate. So at the neuronal level, individual neuron has to, firing units. And we look at network of, neurons and also the cognitive function. We can actually make decision and also in the language processing. So that is what the computational neuroscience does, is models this information I've stated here, decision making, learning, perception, and sensory input. Also model the language. So what are the modeling approaches we are talking about? Of course, we have descriptive model. Descriptive is asking, what is the brain doing? It's trying to understand what is the brain, what is the nervous system doing? And that is descriptive model. Okay, summarizing experimental data compactly without explaining the mechanism. So just like the setup field. Then the next one is mechanistic model. It's asking how is the brain doing this? And that we can actually look at ion channel, like the Hodgkin and Hussey equation. Okay, so the other one is like normative model. The normative model is like, why is the brain doing what it's doing? So these are the different levels of modeling, the approaches. So we have 3 levels of modeling: descriptive, that's asking for what the brain is doing; mechanistic model, that's asking for how is the brain is doing what it's doing; and the normative model is asking why is the brain doing what it's doing. So these quantitative models and computation that decodes how the neuron compute and communicates. Like I say, the applies the quantitative tool to model how neurons compute and communicate. Okay, by physical neuron, well, you have to understand that the neurons are being studied like electrical circuits. For you to be able to model them, you have to study them like what? Electric circuits. So when there's neuron dogma, where you look at how the neurons from the level of the inputs, which is the dendrite that receives an input and takes it to the cell body, and from the cell body it goes to the axon, and from the axon it can actually connect to the other neuron. Okay, so that's the physical property of neuron, which you have to use, model it in electrical circuit manner. So mathematical and the computational methods is essential to decode the brain complexity. So in integration, it bridges experimental data and theoretical framework, okay? Because you are looking at, okay, you can go to the lab, of course, get data from animal or everything, and you have to model it so that you can actually bridge what the data is saying from what the theory says. So this slide is not too good, but it's actually, the slide is talking about the core tools and techniques in computational neuroscience. What are those core tools? What are the things we say? Like I said, when I went to Gatsby Computational Neuroscience, I did a lot of mathematical modeling, okay, where we also, we did some algorithm. That was the first time I heard about Fourier transports, a lot of things. So probability and statistics is a tool, a computational tool for understanding how the brain works. I'll talk about machine learning, supervised and unsupervised, deep learning, and neural data. Also have the dynamical system. Okay, dynamical system. Okay, that tells you that how brain evolve over time. So we also have about the information theory coding and also reinforcement learning. So in reinforcement learning, you talk about where you have the reward, okay, when something is in the state and it has to receive, reward, okay, and punishment. So you have also integration, where you have the model plus the data, and you also make prediction and have your theory. So these are the core tools we use in the modeling computational neuroscience. Sorry, next slide. Sorry. So in the next slide now, we are looking at, this is neural coding. Assuming you want to like record information from a particular neuron or group of neuron, population of neuron, okay? So it could be that you have put your neural pixels, and these things you are seeing here, they are the spike, the spiking action of a neuron. So you can see that if when you come to the first one, that neuron actually spike one. If you go down, this is like population of neurons, you have their spiking, and these are the information you have to model. So the action potential, of course, it is the way the neurons actually, speak to each other that, it has by action potential. So how the informations are coding. So this neural coding will have rate coding. We have talked about firing rate of the neuron, and temporal coding. This actually precise timing carries out information, and population coding. That is when you have group of neurons, you are recording from different types of neurons at the same time, and you see their spiking actions, and this is what it is, and you have to model it. So, like I said, this is electrical circuit that is talking about Hodgkin and Huxley model, which I know Prof by next week when he's talking about the LIF neuron, okay, he's going to be talking about these circuits because he's from the physics background and he has all the quantitative skills to talk about this. So we now talk about the application of this computational neuroscience. CNS is not just a theory, it impacts the real world. What am I trying to say? In the brain-machine interface, we talk about brain-machine interface now, we're not talking about how people can actually use prosthetic hand to, the brain sends information and they can actually move it, okay? You can actually use it in disease model like, stimulating epilepsy, Parkinson's disease, Alzheimer's, okay, to find treatment, and also in neuromorphic computing, building hardware chips. You can actually plant hardware chips just like people that have, Parkinson's disease. You can actually plant chips that can help them to control the tremor that comes with Parkinson's disease. So, tools and softwares, okay? These are the, when it comes to programming now, we talk about the PyTorch, you talk about the neural nets, okay? For detailed biophysical stimulation of a neuron, you have Brain2 for spiking neural network, and you have PyTorch and TensorFlow. And this is actually used for deep learning and the NNN, artificial neural network. And also the SciPy and NumPy, which Prof mentioned, and this one is used for, is a numerical data analysis for, and also for linear algebra. So this is generally, I don't know, I know I was rushing just to meet up with time. So this is the information we have about, holistically about what computational neuroscience is all about. It's not just the programming, it is about, getting your hands dirty in other things, linear algebra, vector, and everything, so that you can actually enjoy this field. It's a very fascinating field, I must tell you that. So I pray that, I know somehow the lecture would have actually somehow, summarize to you what the field is all about. I pray you have gotten some information about this. Thank you very much.
Please, can we appreciate Dr. Chinagorom for that wonderful presentation? Wow. Thank you, Dr. Chinagorom. That was a great one. Thank you. I also learned a lot. Thank you so much. That was a beautiful one. I know we may have one or two questions, but based on our schedule for today, I will quickly run through about a 5-minute presentation. I hope I will be able to get through that, maybe a maximum of 10 minutes. And then Alesso will be able to maybe have us a few feedback. Okay? Now, I've mentioned at one point in time or the other in the course of this series that this platform we are using was made possible by FET interactive simulation at the University of Colorado in Boulder, USA. And it's on that premise, I want to just make a very quick presentation, tell us what it is all about. I haven't enjoyed this privilege opportunity of being part of this training. One of the key sponsors, we have talked about Neuromatch, we have talked about Imbizo and the rest of them. I believe it's also important for us to know what FET is all about and what exactly can we actually benefit from what FET has to offer. So it's on that premise that I'll be making this simple presentation. Dr. Chinagoro, you might need to stop sharing so I can share my screen. I hope I have the privilege to share the screen. Our host, can I share my screen?
Yes, so definitely you can share your screen, sir.
Okay, thank you. Just a minute, please. So while I'm trying to share my screen, I'm trying to look for it, but I don't know what is happening. Okay, just a minute, just a moment, just a moment. Okay, yes, I'm back here now. Okay, so while I'm trying to, I believe you can see my screen now, right?
Yes, definitely. Your screen is coming up, but it's yet to fully show. But give it a few seconds, should be up.
Okay, great.
Okay,
now,
it's up now. It's up now.
I'm giving a very quick overview of what FET interactive simulation is all about. And I'm going to make it as brief as possible, FET interactive simulation was actually a brainchild initiative of a Nobel laureate by the name Carl Wieman. That's the man you are seeing his picture on the screen. He's a man I particularly celebrate and appreciate for his commitment to humanity and especially to STEM education. He won Nobel laureate in the year 2001, and the grant he received from that was what he used to start what is known today as FET globally. He started that in 2002 at the University of Colorado in Boulder, USA. And you can see the URL for that project right on the screen. Is fet.colorado. We pronounce it as FET, P-H-E-T, fet.colorado.edu. Okay? You can try out that link. You can try out that link on your browser and see what the page looks like. I will just do a little bit of demonstration. Now, initially, the name FET was actually targeted towards physics education. So the name Physics Education Technology, the acronym PH was taken from physics, then education and technology. But over the years, in the course of working on this project, it was extended to cover all STEM subjects, including all sciences, technology, engineering, mathematics, and all science subjects, and you can think of, they are all covered in these projects, okay? Now, this is a typical simulation. We call this one capacitor lab. You can actually access them online. It gives you a lot of things you can actually work with. For instance, for those of you who are probably in the electrical side, you can be, maybe you may be familiar with what a capacitor is all about. This is a typical capacitor, a parallel plate capacitor. Okay. Now, this concept is trying to teach you the charging and the discharging of a capacitor. When you connect a potential, a power source to a capacitor, it stores charges, and the charges remains there. Okay. Even when you try to disconnect the capacitor, I've disconnected from the battery, the charges are still stored within this capacitor, meaning it can still electrocute, it can still shock somebody, especially if it's carrying a very huge amount of charges. Okay. Now look at what happens at this point in time. If I choose to connect this to a bulb, watch what happens. You can see the bulb get lighted and the charges in the capacitor has been dissipated. And when the charges are gone, you discover the bulb goes off. This is one of the simulations that we have and it's freely available. This is another one also. This one is trying to teach you basics of energy conversion. how your energies are converted from one form to the other, okay? For instance, you have a young man riding bicycle, and the bicycle is connected to a generator that is converting the mechanical energy from this young man. In fact, the chemical energy starts from this man based on the food he eats, and is translating that chemical energy to what? Is translating it to mechanical energy, which eventually turn out to be translated to electrical energy to boil this water here. I can display the energy at every point in time. So this young man is claiming, feed me. Why? Because the chemical energy that he acquires as a result of the food he ate has been dissipated. So if I click feed me again, this young man gets enough chemical energy again, it continues to ride, and then you see the cycle going on. We can also even display having a solar energy here. All of these are possible with interactive simulation. Now, coming to computational neuroscience, also as part of the 1.1 billions of simulation that are available, over 1.1 billions of simulation available at FET's interactive simulation in University of Colorado. We have one that is called Neuron, and this is just a screenshot of what it looks like, okay? Now, from what you can see, I can zoom a typical neuron. Dr. Chinagoro made mention of neuron as the smallest unit of human brain, and a typical human brain has over of the order of 86 billion neurons. And all of these neurons, as individual as they are, takes input from other neurons and sends output to other neurons, and that is the connectivity that makes human brain to coordinate and to work and carry out functions, okay? And we are looking at the smallest unit of human brain. Remember, we said we have how many? 86 billions of this type of neurons, what makes a human brain, okay? So looking at what we have here, we can zoom to see what is happening in a neuron. That is by simulation. We can also monitor what is happening even at every point time within the neuron. We can also change to make it fast or slow here. We can as well see the sodium ion and then the potassium ion. We can see the gated channel for both potassium and sodium ion and the rest of it, okay? I'll go to the next page for you to actually see the live demonstration of it. This is what it is, okay? Let me reset it, okay? Now, at this point in time, I can simulate this. And on simulating it, you can see what is happening now. Let me go over. Looking at what you see here, this is just like what is causing the spike in taking input from another neuron and then sending its own output to another neuron. And I can also display the charges and over the view here, and you will see how the membrane potential varies with time. This peak you are seeing here, that is at the point when this neuron spikes. Okay, those are some of the basic things that we'll probably see when we are doing Lit Integrate and Fire by next week, all things being equal. Okay, so then going forward, you can actually access this particular neuron directly on this link, and then you can also download it because the beauty of the simulation you have on this FET interactive simulation is that you can actually have access to them to be used online. So you don't have to be on the internet to get access to it. Hence, if you have access to this second link I pasted here, you download an HTML5 file that you can actually run locally on your system, on your mobile phone, to actually simulate a neuron or whatever other simulation you are probably interested in, okay? And then we also have teaching resources available to teachers as well as learners. You will have to register on that site for you to be able to gain access to teacher resources, okay? Now, another beautiful thing about FET interactive simulation is that it's available in so many languages. Name your language from which part of the world you are coming from. You have simulations that have been tailored to your language. That's one of the key things there. So meaning you want to even take science, technology, engineering, and mathematics education to the grassroots. You want to teach people in their own language. For instance, for Albanians, people who speak Albanian, you have about 171 simulations as of the time we compile this. If you are from Morocco, you have one simulation as of now. From Saudi Arabia, you have 80 simulations and the rest of them. These are what you can get access to if you explore this. This is the outcome of some of the training we have actually done in the past for people on the use of interactive simulation. And there is a code that's available online. This is also an interface of some of the physical training we have also done in the past, and the certificate you put hand for participating in this training. Also, this is the certificate that you can actually obtain if you choose to go through the training on Coursera. So a comprehensive training on how you can get to know the usage of interactive simulations available on Coursera is free. And then you can actually register through this link or make use of this QR code so that whenever there is a next call for the training to be open, you can actually be enrolled to participate in that. And on that note, I would like to acknowledge all the stakeholders like Dr. Chinagorum did earlier. I've been privileged to benefit from several organizations globally. They are quite inexhaustive, so I may not be able to mention them one after the other. And so on that note, I want to say a big thank you for listening. Okay, so I think I was able to make it in about 10 minutes. Thank you, thank you, thank you, thank you. On this note, I want to say, if we have questions generally or not that we have done today, it's 8 o'clock on the dot already, okay? But we can beg your pardon to give us maybe extra 5 to 10 minutes to get questions or feedback from you. So you can unmute yourself and ask your question at this point in time. Do you have the privilege of being able to unmute yourself? Or you can...
definitely, okay. Everybody can unmute them.
Okay, good. So do you have questions?
Thank you very much. Yes, I have a question, please.
Okay, please.
It's Chika that is speaking.
Okay, Chika, you're welcome.
Yeah, thank you so very much for the session. Prof, my question is directed to you. Can you please share the last 2 of your slides, particularly the one that is talking about how to get trained on FETs and Coursera?
Okay, right away. I'm doing that right away. Okay, next person, you have that coming up right away. Any other question again? Okay, I have some questions on the comments on the chats. Okay, thank you for granting us to this learning platform. Thank you, all doctor. Okay, we have appreciation from people. Okay, thank you, thank you. Any other question or comments? Okay, so if there are no questions, there are no comments. Let me take final words from Dr. Peter, if there's any. I hope he's still on the call. I know he was having issue with connectivity. Dr. Peter? Okay,
yeah, thank you so much.
For today.
Thank you so much, Prof. Thank you for the way you summarize this huge work in 10 minutes. This work is something that you will do in 10 years. Dr. Chinagoro, thank you also for managing the time well. God bless you. Thank you so much. And thank you, everybody. Make sure you engage with the video. Go to YouTube and then watch this to make sense to you. Thank you, sir.
Thank you. Thank you. Dr. Chinagoro, final words for you from today. For today, final words from you for today.
All the participants for joining us. Thank you, Prof. Peter, Dr. Peter and Prof. God bless you.
Amen. Thank you.
Yeah,
thank you.
perfect.
We have a young man in the house by the name Heritage who has been supporting us technically. A word from you, Heritage.
Hello, everyone. Good evening. Thank you so much once again for joining us, each and every one of us, and appreciation to our great facilitators, Professor Akinola, Olayinka, Dr. Peter, and Dr. Chinagoro. Really appreciate your academic input this evening, and really hope to see you guys as well next week. So, and to our participants as well, thank you so much for making this a great session. Definitely look forward to seeing each and every one of us next week. Bye from my end.
Thank you very much, Heritage. You are much appreciated. Also, I have an apology from Jeffrey. He had an urgent issue.
Thank you.
He couldn't make it around. So once again, thank you everyone for making it today. Please, like I said earlier, keep engaging with the information you've been given access to, and make sure you don't belong to the category of somebody that will just gargle with the information, please. The information we have given to you, the knowledge fountain we have shown you, please drink. Let it, in fact, drink to until you are saturated. Is that okay? Please, the information are meant to make you better. And in the years to come, we would like to welcome maybe some of you to join us at this other end someday to be part of the facilitator. Thank you once again. Do enjoy the rest of your weekend and remain blessed. Bye for now. God bless you. And you can drop your parting words on the chat. And don't also forget to actually comment on a video on the YouTube. You can also subscribe to that channel. It's one of the supporting channels that is also supporting some of the initiatives we are pushing. So please try to subscribe, pass your comments there. Let's have your feedback, and God bless you as you do that. Thank you, and remain blessed.
Thank you. Good night, everyone.
Good night.